In the previous video, we had discussed and we had seen how to generate the beam model. We had assigned the property of the beam. We had assigned the support. And in this video, we are going to see how to apply the external loading. So let's go to this picture. See, on this beam, we have this UVL. Okay, we have three types of UVL loading. We have UDL or uniformly distributed loading. We have a concentrated load and we have concentrated moments. Okay, so before adding this load, you should also keep one thing in your mind is that, and that is you should assign the dead load, because whenever you design a model or you design a structure, since the self weight of the structure is a huge amount, it should always be taken into consideration in the design. Okay, so first I'm going to add the dead load. So how are we going to do that? Click on load case detail, then go to add. Okay, then loading type should be your, see there are different types of loading. So we'll click on dead load. You can keep the title as load case 1. I'm changing the title to dead load. Add, close. Now again select dead load. Again, under this is only a load case detail. Okay, you have not created or you have not assigned the load yet. What type of load is dead load is not yet assigned. So you click on this load case detail, dead load, then you again add, and now you can specify what type of loading it is. Okay, so here, see, first option is your self weight load. Okay, self weight load should always act downwards towards gravity, hence the factor is -1 and your direction is y. So you add it. Okay, close. Now you have to assign the type of load, or you have to assign the dead load, the self weight of the beam, to your structure. How will you do that? You click on self weight. Okay, and I will choose assign to view. I will click on assign to view. What does this option assign to view means? It means whatever structure is available in front of you on the screen, this self weight or whatever property, everything will get assigned to the structure or the model which is available, right? So I'm clicking on assign to view and save and assign, right? See, the entire the self weight gets applied on the entire beam. Okay, now I am going to add this different UVLs and UDLs and concentrated load under live load. Okay, so for that I'm again going to load case detail, add. I'm creating the second load case detail, which is going to be live load. It can be, you can add it under dead load also, but I'm choosing live. I'm changing the title to LL or live load, add. Now under this live load, you have to add the UVL, the UDL, the concentrated load and the concentrated moment. So click on live load, go to add, and then what you have to do is that you have to, I will first add all the different types of loading from these options. Okay, and then when I'm done with selecting the type of loading, I will assign them to the beam one by one. So let's see what are the different types of loading here. So first, you know, there is the self weight load. Now see, we will go to member load. Okay, we are going to member load because all these beams, all these beams are basically our members, and we are going to apply these different loadings on this individual members. Right now under this member load, we have uniform force, which is equivalent to UDL or uniformly distributed load. Then we have the uniform moment or moment which is applied uniformly along the span of the beam. Then we have the concentrated force. Okay, see, for concentrated force only P, this loading P is acting on one single point, or it is concentrated over one single point. Then we have the concentrated moment. Okay, concentrated moment is again, the moment is acting at one single point. Then we have linearly varying. Under this linearly varying load, we have another two options, which is trapezoidal and the second one is rectangular. then we have trapezoidal, then hydrostatic. These options we will see later, but first we have this UVL loading. Okay, in the first span of the beam we have this UVL loading whose maximum intensity is 12 kilonewton. There will be a slash per meter, so we will add this load. Okay, for that we go to linearly varying and we will click on, see, this is the case, this is our case. Okay, the loading is triangular here, and the magnitude, the symbol of the magnitude of loading is W3. So we click on W3 and here we write down the magnitude, or we put the magnitude. How much is it? It was 12 kilonewton per meter. Okay, minus 12 kilonewton per meter. So why minus? Minus, we are putting minus because the load is acting downwards, and in STAAD Pro, upward positive y is basically is the upward direction and negative y is the downward direction. So we are adding a minus before the magnitude. We add it. Okay, it should be acting in the minus y direction, so we add this load. Next we add the UVL. Okay, the UVL loading whose minimum intensity is 4 and maximum is 7 kilonewton per meter. So we click on this. See, this picture is applicable for the trapezoidal loading. Okay, the minimum intensity is written here W1, and what is the value? It is 4. So we write down minus 4, and W2, the maximum value is minus 7. Acting in y direction, we add it. Next, what do we have? Next we have this UDL. Now see, this UDL loading, the unit, the magnitude is 26 kilonewton per meter. But if you consider this beam, right, this beam, this UDL is acting at a distance of 3.5 meter from this support. So that is how we are going to apply the beam in, apply the loading in STAAD Pro. So for UDL loading, you go to uniform force. Okay, see, this is the symbol of my UDL loading, and the intensity is W1. What was the value? The value is 26 kilonewton per meter. So we put the value minus 26. Now you have to specify the distance, right? What is the distance? See, from the start of the beam, the distance up to which, or the distance from which loading will be exerted is D1. So in our beam also, the UDL loading is starting at a distance of 3.5 meter from this support. So D1 here is going to be 3.5 meters. Okay, now how much is D2? D2 is the distance up to which, or the span up to which UDL loading will be exerted. How much is that? It is 1.5 meters. See, this UDL is acting on a span of 1.5 meter. So you provide the value 1.5 meter. D3 is not required, and you should exert the load in the global y direction. Add. Okay, next we have another UDL loading. Okay, which is, if you consider this as a span, as one span of beam, then the UDL loading is starting from the support and it is acting up to 1.5 meters. So let's put the values. The magnitude was same, minus 26. D1 should be 0 because the loading is being applied just at the support, and up to how much? It is being exerted up to 1.5 meters. So my D2 value is going to be 1.5 meter. D3 is 0, global y direction. Add. Next we have this concentrated loading, which is 20 kilonewton. Okay, so let's go to concentrated force, minus 20, right? D1, see, D1 is the distance from the support of the beam. In our case, it should be 0. D2 is also 0, added in the global y direction. And next we have another UVL whose maximum intensity is 10 and minimum is 0. So we go to trapezoidal. or we can also go to linearly varying. Okay, we give the magnitudes. W1, see the maximum magnitude is here. Okay, it is -10, and the minimum magnitude is 0. Okay, at the end of the beam, W2 is going to be 0 because this is the end of the beam applied in the global y direction. Add. Now, next thing is your moment, right? You have to add the values of your moment. One is 15 clockwise direction and 10 anti-clockwise direction. So in STAAD Pro, clockwise moment is taken as negative. Okay, so let's go to concentrated moment. Clockwise, how much was the magnitude? It was 15 minus 15 because it's clockwise moment. Again, give the distance d1. How much is the distance? See, if this is one span, the distance is 3.5 meter from the support. So let's give the distance. D2 is 0. It should be applied in the global z direction, because I've already discussed in classes about the moment with which we work is acting about. The moment is about the z direction. So add. Next, next we have this 10 kilonewton meter, which is anti-clockwise, acting at a distance of 1.5 meter from this support. So it's going to be 10 anti-clockwise, hence positive, and acting at a distance of 1.5 meters, right? 1.5 meters, global z direction. Add. So we are done with adding all the loads. Now we will assign the loads onto the beam. So what are we going to do? We will select the individual beams and then assign the load accordingly. So first we have the UVL load. Okay, the uniformly varying load. So on this span we add this UVL, right? Assign to selected beams. Assign. Yes, see, it's added. Second, we have this span and the trapezoidal loading is acting. Assign, right? Next we have this UDL, uniformly distributed load, which, where should it be applied? I think I did a mistake. 1, 2, 3, 4. There are 4 supports, and yeah, there are 4 supports, and I created probably how many more? Oh, I have created 2 more supports. Anyway, it's okay. Okay, we are going to add this load on this beam. Now suppose there is a change. We add this load on this beam, so assign to selected beams, right? Then we will again assign this load to, where should I assign it? Okay, suppose I'll assign it over here. Fine. And we have a concentrated load of 20 kilonewton, which is applied somewhere over here. Okay, so I click this beam, assign to selected beam, assign. Then we have a linearly varying load. Okay, the linearly varying load is applied to this beam. Assign. Done. Now we have the moments. Now since we have a problem, we have created 2 more extra supports. Let me just go to support and okay, I'm pausing the video right now. Let me just correct the model, and I'm coming over to the I'm explaining the rest of the part in the next video.